All right, so here we are in question 11. So 11 and 12, I told you guys in class that those were going to be arithmetic. And on the test, I'll indicate what I want them to be. But again, I'm going to have to set this up like I did on number 9. I'm going to set this up as a system of equations. So on 11, I get 768 by taking the first term plus d times n minus 1. And since n is 5 in this one, I'll end up with 4d. And then I get 12 by taking the first term plus d with n minus 1, and since n is 2, I'll just have 1d, which I don't even need to write the 1. But now I'm going to subtract them. So when I subtract my constants, I get 756. The a's go away, and 3d. And when I'm done, d ends up being 252. And now I can find the first term, and I'm going to find the first term by taking 252 and putting it into the smaller amount 1. So when I do that, and I'm going to subtract to get a1 by itself. A ends up being negative 240, my first term. And so now I can write the rule. And the rule goes by taking the first term plus d, which we figured out was 252 with n minus 1. And I'm going to clean it up. I'm going to distribute. And when I'm done, my final rule is, I'm going to move back up to the answer space though, is 252n minus 492. And now to find the 15th term, I'm just going to put it into my rule. And when I put 15 in there, multiply and then subtract, I get 3288. 12 is going to be the exact same setup. I'm going to go ahead and set up my system. So I get 3,888 by taking the first term plus n minus 1, so 4d. And I get 108 by taking the first term plus n minus 1, so 2d. Again, I'm going to go ahead and subtract. And when I do that, my constants give me 3780. My d's give me 2d. So when I'm done, d is worth 1890. And then I'm going to plug that back into my smaller amount of my two systems of equations problems. So I'm going to put d in there. And when I do that, I get 108 equals a1, and then 2 times 1890. And after I subtract, to get a by itself, a1 ends up being negative 3672. And now I'm ready to write my rule. I'm going to go way down here. So the rule comes from the first term plus d with n minus 1. Okay, so I'm going to distribute my 1890. And when I'm done cleaning it all up, I'm going to move back up to the answer blank. My rule ends up being 1890n minus 5562. And then my 15th term, once I put n in there, is 22,788. And again, you guys, just so you know, you can use n, you can use x, you can use whatever variable you want. Okay? All right, let's go to the back page. So on the back page, I'm going to be using my series shortcuts. So I really do have to pay attention as to what shortcut I'm going to be using. Okay? And again, you're going to be giving these formulas, but for now, you'll have to look at your notes. Okay, starting with the first one, number 11. Again, I still want to check to see, is this arithmetic or geometric? So when I look left to right, it is not consistently going up by the same amount. When I go from right to left and look for my ratio, it is never consistently the same. So at this point, what I'm going to do is write the term numbers above the terms and see the pattern from there. And this one is a simple pattern. It's just x squared or n squared or whatever. But now I'm going to put my sigma with it, and since I chose x, it's going to be x equals 1. I have a total of 5 terms, so my upper index is 5. 12, as I look at it, I have 5, which I can make into 5 over 1. This ends up being arithmetic because my numerator always stays 5, and when I look at my denominator, it's consistently going up by 1, which is also the term number. So there is my rule, 5 over x. Putting it in summation notation then, with my sigma, I'm going to have x equals 1, and here I have 5 terms. So there's summation notation. 13 is also arithmetic. The numerator is consistently going up by 1, and so is the denominator. As far as the numerator goes, the numerator is the term number. Take a look. So that's x, and the denominator is just the term number with 1 more. So put my sigma with it. I start with 1, and when I'm done, I actually had 6 terms here. All right, so let's take a look at the next. These are all going to be shortcuts. So if it's arithmetic or geometric, I'll put an A or G. Otherwise, it's one of the 3 basic shortcuts at the top. So as far as 14 goes, 14 is going to be, this is the shortcut. It's just going to be a modified version. So taking a look at 14, again, it's this shortcut, but I'm going to view it, as negative 1 times x. So I'm going to follow the shortcut for x, and that says I take n, which is 5, and n plus 1 more, which is 6, divide by 2, and when I do this math, I get 15. But now I'm going to take that 15 and modify it by taking it times negative 1. So when I'm done with that, my answer is negative 15. All right, let's take a look at number 15. Because when I look at the rule, it's arithmetic. This is going to be my arithmetic shortcut. So again, just going back to the formulas, I'll be using this one. This is my arithmetic shortcut. And that shortcut says I take, again, just looking at it, the term, however many terms I used. So in this problem, it's 35. And then in parentheses, I take the first term. So when I put 1 in for n and do the math, I get 88. And then I want to subtract the final term. So when I put 35 in there, I get 20. And I'm averaging that out, so I divide it by 2. So I'm going to go through, add, divide by 2, multiply by 35, and when I'm done, my sum is 1890. All right, 16 is geometric. You have to be careful on 16 because usually the geometric is n minus 1 as the exponent, and this is n. So this shortcut, if we go back and look, says I take the first term and then my parentheses of 1 in r's. But here the first term might look like 1, but it's actually 4, because if I put 1 into my exponent, 4 to the first power is just 1. So my first term is 4. And then in parentheses, I'm supposed to take 1 minus r, which is 5 to the 4th power. And then, I'm sorry, I wrote that backwards. 1 minus 4 to the 5th power, and then 1 minus 4. And again, we talked about what can you do with your calculator. First, I would turn your denominator into negative 3. And then I'd go to the calculator, type in 1 minus 4 to the 5th, which is negative 1023. Then I would divide that by negative 3. And when I'm done with that, I'm going to take that times the 4. And when I'm all done with this, my final answer is 1364. That's the sum of that series. 17 is also linear. So I'm using that shortcut, and it says take the number of terms, which is 15. Take the first term. So if I put 1 into I end up getting 7. Plus the last term, so I'm going to put 15 into I, and I get 49. Average it out by dividing it by 2, and when I'm done, I get 420. That's after I've multiplied by 15, though. 18 I'm going to come back to in just a second because I'm going to have to space this out a little bit more. 19 is also linear because if I do break this down, this is 1/3 n plus 5/3. But for the sake of the formula, I'm going to leave it as is because it works out really well. So the formula says I should take, again, the total number of terms, which is 28. And then I'm going to take the first term. So if I put 1 in there, 1 plus 5 is 6. 6 over 3 is 2. And then I'm going to put my 28th term in there. So when I take 28 plus 5, that's 33. 33 divided by 3 is 11. Average it out, dividing by 2, then multiplying by 28, and I get 182. Okay, so 18, kind of on the assignment that we checked today, there was one where we estimated the decimal, but that's what's going to happen here. So letting your calculator help you will be very nice for this one. So This is the geometric one, and so I need my first term, which is 3. And then in parentheses, I should have 1 minus r, which is negative 1/3 to the nth power, which is 20. And then over that, I'll have 1 minus negative 1/3. So the first thing I'm going to do, excuse me, is get the denominator cleaned up. So 1 minus negative 1/3 is 4/3. And then I'm going to type this into my calculator as far as the numerator goes. So I'm going to type this in just as you guys see what I'm highlighting. I'm going to put that negative 1/3 in parentheses to the 20th power. And when I'm done, the calculator is going to give me an amount that's really close to 0. Because think about negative 1/3 to the 20th power. That's a really small number, and probably the best way to describe it is just saying it's about 0. So as far as the outside goes, I still have 3. In my numerator, I have 1 minus an amount which is practically 0 over 4/3. So basically that ends up as 3 times 1 over 4/3, which if I just multiply by the reciprocal becomes 3 times 3 over 4. And when I'm done, I could have 9/4 as my answer. If you want to put as the decimal, that's great too. It's about 2.25. Okay? All right, let's go to the bottom row. Well, not almost the bottom row. So bottom row is one of the shortcuts at the top of what you're seeing. It's the one all the way to the right. And that shortcut says that I'm going to take n times n plus 1 more, so that's 13, times n doubled plus 1 more, and that's 25. And I'm going to divide all of that by 6. And when I do all that math, I end up with 650 as my answer. The next one's geometric. So again, what I'm going to do is I take the first term, which is 2, and then in parentheses 1 minus r, which is negative 2 to the nth power, so that's 10, over 1 minus negative 2. Again, I'm going to start with my denominator, turn that into 3. Negative 2 to the 10th power is 1024, so just kind of continue what I have. So I'm going to take 1, subtract 1024, which gives me negative 1023 divided by 3. Take that times 2, and when I'm done, I have negative 682. All right, let's go to 22. For the sake of room, I'm putting 22 over here, and I'm going to write it in red. So this is also geometric, and geometric says I should take my first term, so I've got 4, and then in parentheses 1 minus r is just 3 to the nth power, so 5 over 1 minus 3. The first thing I'm going to do is change my denominator into negative 2. And then I'm going to take 1 minus 3 to the 5th power. And when I do that, I get negative 242. So I'm going to divide negative 242 divided by negative 2, take that times 4, and when I'm done, I get 484 as my answer. All right, with not much time left, I paused it, quickly wrote down the number of rings compared to the number of moves. The number of rings is like my term number, and the number of moves is my term. Looking at arithmetic, it's not going up by the same amount. Geometrically, there's not a common ratio. So after a little bit of thinking, I realized that to go from the ring to the number of moves, that it's 2 to the nth power minus 1. Now, somebody asked, what if you don't get that? Well, if you don't get that, then come up and talk to me. I will try to give you some clues as best as I can. So the final question is, what's the minimum number of moves required to move 6 rings? I'm just going to put 6 in for n. 2 to the 6th power, 64. Take away 1, and I get 63. And that's it. We'll see you on Monday.